Now the second thing we want to talk about in this section is free fall acceleration. Free fall acceleration is any time an object's accelerating due to gravity, just the force of gravity. And the force of gravity always pulls objects towards the center of the Earth. So this acceleration will always be pointed towards the center of the Earth, which in our case is usually thought of as down. We always think of what we feel as down as towards the center of the Earth. The acceleration of any falling object, when we do not include air resistance will not be included in most of the problems that we cover in this course. You can assume that air resistance is not included unless it is otherwise stated. So the acceleration will always be 9.81 meters per second squared towards the center of the Earth any time that an object is falling, when that is the only force. This is the same for every object regardless of mass, and this was first discovered by Galileo. Now, a couple of key things to think about when an object is thrown upward into the air if it's just not falling. If it's thrown upward into the air, it's going to have two parts to the trip. It's going to be traveling up and then back down. These would be straight on top of each other if there's no horizontal velocity. So it's going to have an initial velocity. The key point is it's decreasing in speed as it rises. It will decrease in speed until it reaches the highest point. At that highest point, the velocity is always 0. Then it will gain speed coming back down, still accelerating at 9.81. It accelerates at 9.81 down the entire time. So when it's traveling up and accelerating down, it's going to be slowing down. So slowing down as it goes up. And then speeding up as it goes down. It will reach a final velocity that is the opposite of the initial velocity when it gets back to its original starting height. So whenever you throw something up into the air, if it starts at say 10 meters per second, it will decrease that velocity until it gets to 0. 0 will be the highest point, and then it will pick back up that velocity, increasing in velocity, now going down, so being negative if we make up positive. And it will reach the original starting point at the opposite of the initial velocity, so negative instead of positive. The acceleration the entire time is 9.81. Even at the highest point when it is not moving, it is still accelerating at 9.81 down. So let's look at some example problems with this concept. An egg is dropped out a window and falls for 3 seconds. What is its velocity after 3 seconds? So its initial velocity will be 0 meters per second because it's being dropped. Its acceleration will be 9.81 meters per second squared going down. Its time will be 3 seconds, and its final velocity is what we're going to look for. So the equation we have that has all of these is v final equals v initial plus at. Now everything is down, so I'm going to make down positive in this case. So everything that's down will be positive, and the only thing that has direction here is acceleration. So v final equals 0 plus 9.81 times 3, giving me a final velocity of down 29.43 meters per second. I know it's down because it's positive. A second problem, a ball is thrown upward at 4.9 meters per second. How long will it take to reach its peak? How high will be its peak? And how long will it take to come back to its starting point? Now my starting information, I'm going to put it down here in the corner, will be an initial velocity of 4.9 going upwards, an acceleration of 9.81 going down. So I need to make one way positive and one way negative. I'm going to make up positive in this case. So this is my starting information here for all the problems, which means if I make up positive, the acceleration must be negative because it's going down. Now the rest of the information, I know at the peak, its final velocity will be 0, and I'm looking for the time. So with those four variables, the best equation, Vf equals Vi plus At. So 0 equals 4.9 plus negative 9.81 t. Positive and negative is very important. This is going up, the acceleration is down, so they must have opposite signs. So subtract both sides by negative 4.9, divide, and I get 0.5 seconds. Second problem. I now know the time is 0.5 seconds, and I'm looking for displacement. So I need displacement, time, initial velocity, and acceleration. So now the best equation, delta x equals vit plus 1/2 at squared. So delta x equals 4.9 times 0.5 plus 1/2 negative 9.81 times 0.5 squared. Plug this into my calculator. 4.9 times 0.5 is 2.45. Half 9.81 times 0.5 squared comes out to negative 1.23. Subtract, and I get 1.22 meters. Third problem, how long will it take to reach its starting point? I know my starting point will have the same velocity as where it started, except in the opposite direction. So now my velocity will be negative 4.9. Acceleration still negative 9.81. I'm looking for, I know my initial velocity is 4.9, and I'm looking for time. So I will use VF equals VI plus AT. So 4.9 equals negative 4.9 plus negative 9.81 t. Subtract 4.9 from both sides, I get 9.8, or add 4.9 to both sides. Actually, I switched those. That was a mistake. This should be negative. So this will be negative 9.8 equals negative 9.81 t. T is 1 second. And you should see the time to the peak is half a second. If it takes half a second to get to the peak, it will take half a second to come back to the ground. So a total time of 1 second. Twice the time to the peak will always be the time to the starting point. Okay, you drop a penny off of Taiwan's Taipei 101 tower, which is 509 meters tall. How long will it take to hit the ground? So in this case, I know my displacement is 509 meters down. My acceleration, negative 9.81 meters per second squared down. My initial velocity, since it's dropped, is 0. And I'm looking for my time. So in this case, the best equation, delta x equals VIT plus 1/2 AT squared. So 509 equals 0t plus 1/2 negative 9.81 t squared. 0 times t will be 0. Half of 9.81 is negative 4.905. Let's divide 509. If I made down here negative, here's a mistake, a little change I forgot to mention. Make down here negative, you've got to pay attention to direction. I didn't do a good job of that at the beginning. That means this has to be negative, which means this has to be negative. Since everything is down, we made down negative. When I divide 509 by negative 4.905, I get 103.77 equals t squared. T equals the square root of 103.77. And it would take 10 seconds. 10.18 if you want to be more precise. Okay, one last, much more challenging problem. Car accelerates at 14 meters per second squared for 18 seconds. When the driver sees a stoplight, it slams on its brakes, accelerating at negative 12 meters per second until the car comes to a stop. What is the top speed of the car? How long will it be in motion? So we need to break this into two parts. The first part, the acceleration is 14 meters per second squared. The time is 18 seconds. The initial velocity was 0, and we're looking for the final velocity. So we'll use V final equals V initial plus AT. V final equals 0 plus 14 times 18. So our final velocity, 252 meters per second. So that answers part 1. Now for part 2, our initial velocity is 252. Our final velocity is 0. Our acceleration is negative 12. And we're looking for the time. So V final equals V initial plus AT. So 0 equals 252 plus negative 12t. Negative 252 equals negative 12t. So now the time would be 21 seconds for it to come to a stop. So to answer the question, it took 18 seconds plus 21 seconds. So the total time in motion would be 39 seconds. The online homework will give you a lot more examples of these types of problems to work. Please make sure, though, to write out all of your work, just like I've been doing. Show all of your variables, show the equation, and then show all of your work. Get in that habit before tests and quizzes.